So this is going to be the last session today, the first day of the trainings. I'm going to discuss the pre-trained pipelines with you. It's going to be healthcare specific. When I say domain specific, it means we're working on healthcare. And remember from the second session or my first session, there is the option to use a pre-trained pipeline, which are already in the Models Hub, or you can define your own pipeline. And there are pros and cons for each option. The first one is, see, I just made it bold. They are ready to use, so they are trained models combined together in a probably long pipeline and saved as a pre-trained pipeline, so that it's like plug and play. The other option is defining your own pipeline using multiple NERs in some cases and some resolver models if needed, some summarizer if needed. So it makes things easier. In the third bullet here, they consist of multiple processing stages. I'm going to show a long pipeline to you. It's at the end of the notebook, and I'm going to get results. It's just, as I said, plug and play. It's just one single line of command instead of defining your pipeline. So there are pros and cons, as I said. And always the starting point is raw text input to the final structured output. So like this one, remember from my first session, you get a clinical report like this one with the symptoms, previous illnesses, dosage of the medication, all the medication, past history, past medical history, lab results type of thing. These are mostly the starting point. So again, I'm referring to the first session. Almost always unless it's summarization or some LLM output, it's going to be entity recognition. So NER models, we need the NER models, and we need them to be very accurate. And in many cases, like in the USA, these resolver models are very important. There are codes for like the symptom, like the diseases or the medicine or even lab or tests. So we use the NER model to get the NER first, then we get the resolver models by using these models. And assertion or negation in some cases is also very important. Assume that the patient, let's say he has 50 years of age, and he has some history of medication. Let's say 20 years ago he used some medication, but he does not use anymore, or he had some symptoms, or he had some diseases which were treated or cured by the doctor, and he doesn't observe these symptoms anymore. So if you use NER alone, it's going to get you all the entities. And if you don't use assertion, it will say that, okay, this patient still has these medications, or on this medication, or he still has these diseases. So it's important. Relation extraction is another one we use. Again, the starting point is NER. You start with let's say you want to understand the date for the cancer surgery. So the NER model, one NER model is going to get you the date. Most often the other NER model is going to get you the surgery, and then you will be able to establish the relationship between these two entities, in this case, the date and the surgery. So they are very useful. And the identification, David mentioned this today, the identification is very important because there are HIPAA rules, so like HIPAA identifiers. So this one is some California, but these are identifiers. These are federally defined, I guess. The name, all the name, phone number, emails, SSN, medical record numbers. These are identified as identifier or defined as identifier, and we have to get rid of them. We have to mask them or just obfuscate them. I'm going to discuss this in short time. So for this notebook, you need a license key, and probably you got the email showing your license key. I already started the notebook, and my license key is 5.4.1. Probably it's going to be, yours is going to be 5.4.1 or 5.4.2. So similar to the first session, I just downloaded or got the list of the pre-trained pipelines. This time they are healthcare and they are in English. So we are going to discuss some of these. They are very useful, as I said. I'm going to discuss first what a custom pipeline means. So I define this as a function. You see that the first 4 stages are almost always the same. So you start with document assembler, you get the sentences by the sentence detector, then use the tokenizer. And in many cases, it's going to be, not in this case, but it's going to be the embeddings for NER model. So after that, you use an NER model. In this case, NER clinical. Remember, we discussed that it extracts only 3 entities, problem, test, treatment, and then NER converter. This one is very useful. Medical birth force sequence. Again, this was discussed by David. So it's an NER model. Birth force sequence, if you see birth force classification, it's going to be classification model. But in this case, you see that we get this to understand the ADs or adverse drug events in the text. And NER clinical is going to get you the diseases, the treatments, and the tests or similar things. So assertion model is very important. I'm going to show you the visualizer, but normally it's going to, let's say, you start with this document, past medical history. So you see that the A1C result was in 2020, so it was in the past. So it's, if there's a recent result, it's going to be present. So we use these assertion models to get some negation. If, let's say, let's say the patient had no symptoms or no headache, the NER model is going to get the headache, label it as a symptom, but if you use the assertion model, it's going to be absent. So they are very important. And then you may see that we use the pathology model, pathology family. These models are going to get you all the details about the drug, 6 or 7 entities, but I whitelisted to only get the drug and the dosage and the duration of the drug. And NERDI, this means that that's a de-identification model. It's going to get you, remember the HIPAA rules, those identifiers are going to be extracted by the model. So to make a correct de-identification, first you have to use an NER model to find the entities. So it's going to get you the name, date, social security number, license number, MRN, all of these. And you see the identification annotator is in this stage. So I'm going to show you what this means, by the way, instead of trying to tell. So this is the, remember from the first session, this is the demo page. So the identification has a separate section here. So there's a live demo, which means that you can just paste your own text here to see what's gonna do. So so this is like a short text. You just put your text here and get the masked or obfuscated text. Mask means, as I said, the NER model is going to find the identifiers here, like the hospital name is an identifier, all the address information, almost all of them are identifiers. Email, phone number, medical record number, all are identified here by the NER model, and the name is right here. So if you want masking, the model or this annotator is going to just mark this one, say that it's a street. But obfuscation means the model is gonna, the identification annotator is gonna get some fake, let's say, name or address or SSN phone number type of thing. So it's a, let's say, question of selection. So some of the users want to get obfuscation, some of them want to get masking. So you may use any of these, and the identification is happening at this stage. And again, another assertion model, part of speech, dependency, and relation. So if you see part of speech, it means that you're going to get the relation extraction. You're going to use the relation extraction model here. Part of speech is going to get you the part of speech of the token in this case, and the dependency is going to show you the dependencies between different tokens. So the input columns are shown here. I'm going to use a generic array, which means that I can define the relation between any entity that I want, but there is no definition. I didn't define any entities. So it's going to get you all the relationship between different entities. And chunk to doc, this annotator is used for changing the type of the input column. In this case, this is in chunk format. We want to chunk type, we want to convert it to document type, so that we are going to use the BERT sentence embeddings. And this SBioBERT, Siamese BioBERT, we use it mostly for getting the resolver codes. And in this pipeline, you see that we are going to get the ICD-10 codes and RX norm codes. ICD-10 codes are used for getting the diseases and symptoms. RX norm codes are used for getting the drug information. And the models are right here. And the final section is medical summarizer. So as I said, this is a custom pipeline. You can define it. You can get all you need. But instead of that, we have some pre-trained pipelines here, all listed here. And again, let's go to our page, Models Hub, and just filter for healthcare, and then filter for English, and just get the pipelines. You see that we have almost 1,000 different pipelines that you can use. So this one, the very first one, is going to get you the medication codes. Let's click on it. So which means that you're going to get the drug dosage, frequency, route, strength of the drug here. You're going to get all of these. And then the codes, so UMLS codes, NORMAD codes, NDC, and different NDC codes by using this model. And at the very first, you're going to get the RX norm code. So that's very useful. I mean, I said one line because you just import the library and then you just run this one, medication resolver pipeline, this code, and then you're going to get everything you need. So we have different pipelines here. Let's check. I mean, I don't want to read all of these, but you're going to see what we get by using these models. Let's start with the identification. It is a little small, maybe. So there are links here you can follow. And remember, we discussed the different identifiers here. So these are the models are gonna, you can use these models to get these identifiers. These are pre-trained models. These are pre-trained pipelines. And this one is the very first one is used for multiple languages, and the other models you can use only for English. And similarly, there are different options for different languages here. And in the first one, you just import the pre-trained pipeline, and once you run it, you're going to get the model. So the starting point in this case is similar to the text that we used before. So there is a date here, and there is a doctor's name, which is an identifier. That's the patient's name, and that's probably an MRN number. It's another date, another name. So let's annotate this. Not a full annotate, but let's annotate. And the keys are right here. Not many options in this case because it's not a full annotate, but you're going to get the sentence. The original sentence is right here. So you see the document is, the original text is here. The splitter, the sentence detector, just got different sentences here. So we can get the sentences and then get the obfuscation form. So the first sentence, there's a record date. The date is obfuscated. There is a doctor's name. The doctor's name is obfuscated. So there is no masking here, as you can see. That's just a fake name, considering that this is the one on the left column is the original. And again, the patient's name is gone, the age is gone, and MRN other dates all are obfuscated. So the identification is very important and it's very popular. Resolver pipelines, let's discuss them. So they are very important for insurance companies because let's say you go to a doctor or a hospital, you get some treatment. The hospital is going to send these codes to the insurance companies to get the payment from the insurance company. So these models are they have to be very accurate. So we have, as you can see, again, I just want to make sure that you see how to use it. So again, I go to the healthcare repo, and this is notebook number 3. I know that because I use it a lot. But you can also go down to understand the clinical entity resolution. So you can go to the notebook number 3, or you can use different options by about the entity resolution. Probably on Wednesday or Thursday, there will be some discussion about HCC codes and risk adjustment. So if you go to the notebook, so this notebook is going to give you a lot of ideas about how to use it. So you can see that there is a section to how to create your own pipeline by using this ICD-10 detailed model, or you can get the similar codes for CPT, SNOMED, LOINC, UMLS, HPO, and others. So coming back to our original notebook, so these are the pipelines. You don't have to, as I said, I'm repeating myself, but this is important. So you don't have to create your own pipeline. You can just use these pre-trained pipelines. Or you can, like I said here, ICD-10, you can just write down all the stages and create your own pipeline. As I said, there is a pro for using this. You can make changes in any stage. If it's the pre-trained pipeline, the changes that you can make are limited. So let's get the ICD-10 codes for, again, this lady has some diabetes related to pregnancy, plus this one, and also some hemorrhage. So I run it. Let's get the keys here. So we are going to get all of these. We are only interested in some of these. We got the ICD-10 codes and the chunks. So the model, the NER model, remember the stages for like this one, the pre-trained pipeline has similar stages. The first one is NER clinical, just whitelisted for problem. Just get the problem entities. And then the other model, resolver model is going to get you the ICD-10 codes. So the first one is this diabetes is extracted by the NER model, again labeled by the NER model, and the second model, resolver model, is going to give you the ICD-10 code. And this anesthesia, it's again extracted by the NER model, labeled, and then the ICD-10 code is here. And these are again the final symptom or syndrome or disease, again extracted, labeled, and the ICD-10 code is right here. So they are very useful. There are also task-based PP or pre-trained pipelines like this one. If you're interested in getting the clinical doc generic. So what I mean by generic or granular, let me show you. I have to mention maybe one of the most important models. It's NER-JSL. Again, I'm on the model sub. NER-JSL, you can see that extracts more than 80 different entities. The changes here, there are different entities like the kidney disease. And I'm going to go to the NER clinical to show you the difference. Romanian comes first. Interesting. NER. Oh. Clinical events. Interesting. It's not here. Not this one. So the other model, I was gonna say that it's just gonna get you the model, or the model is gonna get you the symptom or the disease as just a problem. But in this NER-JSL model, you're gonna get a separate entity for kidney disease, separate entity for hyperlipidemia, or separate entity for heart disease, oncological. So it's more detailed, or cerebrovascular disease here. So there, it depends on your choice. So if you want to get more generic names, you can use this pipeline. or for granular, you can use this pipeline. And in some cases, if you're interested in getting the biomarkers, you can use this one. Just follow the link. So the model is going to get you the NER is going to be biomarker, and the biomarker result. There is also a relation extraction model is finding of, which means that the model is going to get you the biomarker, and the biomarker result is going to also show you which is which. So let's say that's a positive, it's a biomarker result, and I'm checking the data frame here. CD9 is the biomarker, so the positive is the finding of CD9, let's say. And there is also a classification model here. It's gonna get you, it's a binary classification, so it's gonna give you if the sentence or this text involves any biomarkers. So it goes all the way down. There are similar pipelines here. You may take a look at them. So let's start to take a look at the oncology. There will be a session, a specific session about oncology models on Wednesday, and it's a very detailed, nice session. So I will just go over these. So you can see that, again, let's go to the page of this one, Clinical Doc Oncology. So we know that by checking the models page, we know that all these entities are extracted by the model. These are NERs. There is also assertion like present, absent, possible, past, family, hypothetical. And there is also relation extraction models, which means that is size of, it means that probably it's a tumor size. Biomarker is for finding, probably date for surgery or the diagnosis. Again, location is probably for the cancer or the tumor location. So this model is very helpful, or this pre-trained pipeline is very helpful. So you can see all the details here. Let's run it. So on this text, it has certain size, not too small, but you're gonna run it and it's gonna be in your environment. And you can see that all these NER oncology family models are used. So that's the basic NER oncology model. It's going to produce this chunk. And this one is anatomy and response to treatment. So this model is going to give you if there are mentions of response to treatment, to this cancer treatment. So there is pathology, which means that cancer-related drugs are mentioned in the text. This model is going to get you these entities. TNM is for staging, and this one is new. It's going to give you the cancer type. And also NER JSL. JSL, remember this detailed model. It's probably certain entities are used. You don't want to get all of these from this model, so probably oncological is used for this one. And pathology model is used. So you see that there is 1, 2, 3, 5, 6, 7, 8 NER models are used to get very detailed information. Let's focus on this one. So, and remember, we merge the NER results at some point and then get the results as a certain merged NER. And then we have the dependencies. So we use, as you can see, we use two different RE or relation extraction models here. So we have the pipeline tracer. It's the pipeline tracer is helpful to see which stages, or you get information from what stage. So in this pipeline, we see that we have NER, we have assertion and relation, but we don't get any summary. So you can easily define it, but it's not in this pre-trained pipeline, and we don't get the resolutions or the ICD-10 or ICD-0 codes. There is no resolution or resolver model in this pipeline. So the other one is pipeline tracer. So you can easily see the model's name. Pipeline output parser is very important. It's going to get you all the details that you're going to need. So once I run it, you're going to see these are all the details. Let's say there is the chunk is CT. It was assertion. We don't see the text in detail, but it was the assertion label was passed. There's a certain confidence on this one. And let's say This one is a chemotherapy, labeled as a chemotherapy coming from, or the NER oncology model just extracted this entity. So it's going to get you a lot of information that you will need. And remember, we will also get other details. So the parser, pipeline output parser, is going to get you the full document plus all the chunks that were extracted by this model. And let's get to clinical doc granular. You see that NER JSL and assertion JSL, and also some relation extraction model is used here. Let's run it and see. And you can see the stages here. So you can see that this is the first NER model, NER JSL. There is not a second model, but there is a different converter probably for assertion model. The second converter is for the relation extraction. And we also use the posology model for getting the entities. And then we merge the results. So let's run this one, this text. The keys are here, and we are going to use the JSL NER chunk to see the named entity. So you see that the NER model, unless you whitelist or blacklist any entity, the model is going to give you all the details. So the heart murmur, yes, it's a heart disease, may also be a symptom. Echocardiogram, it's a test, that's a date. So you're going to get all these entities. So you remember the starting point is a text, unstructured text, and the end point, once you run this pipeline, you're going to get a, let's say, structured data frame, which you can save as a JSON or a CSV. And remember, from this second session today, it's easy to visualize all the entities. An assertion, it may be very important in some cases. You want to see if the, let's say, the heart murmur it is still the case or not. So the assertion model says that it's not a case right now. It's probably the patient had this problem, but not right now. So you can also use the assertion visualizer. Relation extraction is important. So you can see that this detailed data frame, there are two chunks here. We are trying to use the relation extraction model to establish relationship between two chunks or two entities. The first one is heart murmur, which is test. Okay. Oh, excuse me, heart disease, and the other one is echocardiogram, ECG. So that's there is a relationship between these two, the high confidence. And again, heart murmur and date. So the date was that. So you can easily get these, and it's also possible to use a relation extraction visualizer. So you're gonna get all these details and site cancer, all of these by using this model. It's going to give you a lot of detailed information. It is also possible to use with the transform. You see that you can easily define explode the results to get the data frame that you want. You can add some columns or you can remove some columns. You can add the assertion to the columns easily. And it's also possible to get the relation extraction related entity. So it's going to give you all the tokens and the part of speech. Remember, in the second session we talked about these. So admission, discharge, and you're going to get the results easily. So I already run this before the session. I already ran this custom pipeline. It's going to take some time because you see that there are more than 20 stages, plus some of them are heavy. Resolver models are heavy, summarizer is heavy. So I run this one. So let's see, let's run the pipeline tracer. I guess I have to run this one. So let's take a look at the stages. You see that we have the NER clinical model here, and I use the assertion JSL. We have the posology model here, the identification model, because we are going to do some de-identification here at this stage. And chunk merger, maybe I can spend some time on chunk merger. What I mean by chunk merger is We get the results by clinical NER chunk. I am checking the output column. So clinical NER chunk is coming from NER clinical. And the other one is pathology NER chunk is coming from NER pathology. So we just merge the result to get a final, let's say, merged NER chunk. And remember, the identification is important, but we don't use the merged NER chunk as the input. We just use the, well, where is the de-identification? We use the results of the de-identification. NER chunk is right here. We use the result of this NER de-identification. So de-identification is right here. Then these 3 stages are for relation, and then these 2 stages, excuse me, these 6 stages are to get the RX norm and ICD-10 codes, and the final stage is for summarizer. So I just ran it. We get the explain clinical doc oncology. So define the column maps and see what we have here. So you see that we have a very detailed result here. So the starting point is the text, and then the starting with the identification. So the identification model got this one labeled as a name with a high confidence, and then the age again with a high confidence. Let's go to clinical. So vomiting is identified as a problem by the NER clinical model, again with a high confidence. Poor appetite, yeah, okay, it's a symptom. Polydipsia, again, remember the NER clinical model just labels anything, any symptom or disease as a problem. So that's a duration coming from the NER pathology model. You see that for 6 months. Again, this one is dapagliflozin. It's a treatment by NER model, but it's also labeled as a drug by another NER model. So you see that the labels may be different, but both models were able to extract these. So let's switch to what else we can do. These are very useful format, the JSON format. You can also get them as a data frame and then save as a CSV file. It's very important. All the confidence information is here. You can define a threshold. You can say anything below 50%, just ignore it. And these are the entities. And this one is for the assertions. And again, you can just get the results for the resolution. So let's take a look at the resolutions here. So this one is for RX norm, and amoxicillin is extracted by the model from the text. It's labeled as a drug, and the RX norm code is right here. And this is the resolution or the definition. This is coming from the model, not coming from the text. So the resolver models are going to give you also alternative models. So this one, in this case, amoxicillin 3705767, excuse me, 576 is the code by the model. This is probably the best result, but also the model is going to give you some alternatives, because there will be, let's say, this one is for 20 milligrams, the other one is going to be 40 milligrams. So it's going to give you some alternative results. So this one is RX norm. And then I go down, these are ICD-10 results. So you see that gestational diabetes, ICD-10 model says that O24.4 is the code for this, and gestational diabetes mellitus is coming from the model saying that, okay, this is the chunk extracted from the text by the NER model. This is coming from the resolver model, but this is coming from the resolver model again. And also plus O24.4, O24.41 will be the alternative. So these are KNN, I mean KNN distance. This model says that these are the next, the first one is okay, the next, and you can define the number. it's up to 25. Default is 25. These are also very close results, so you can use them. And it goes all the way down. So you can also get the relations again by using this. And let's get the identification. So the starting text, remember the identification model is gonna split to text first, and then you're gonna get the obfuscation and masking here. So Aura Hendrickson with the 28-year-old female with this disease. Disease is not an identifier, remember, it's not gonna be de-identified, but the name is de-identified. In obfuscated, it's a fake name plus some fake age. You can define the age range, by the way. It's not going to give, if the patient is 8 years old, it's not going to label it or the obfuscate it as 85 because the diseases may be quite different. And the last column on the right is masking. So remember the NER model got the name Aura Hendrickson, it's now masked. And age 28, again, it's masked. And the final data frame is running the classification. So you run it, and this model is going to show you if this sentence includes any ADE or adverse drug event. So in this case, you can see that the first sentence involves some ADE. Do you see? Yeah, let's say the number 2. She had dry oral mucosa, so probably it's related to the drug, so that's why it's labeled as a sentence which contains ADE. And the last one, there is no ADE, so it can be useful. So a quick summary, we have very useful pre-trained pipelines. You can also define like the custom pipeline shown here, not always very beneficial. And there will be problems, errors in the beginning. So the pre-trained pipelines details are mentioned here. You can go all the way. Depending on your use case, you can find the pipeline. The links are also provided here. And then these are the identification, but task or resolver pipelines here, you need UMLS, the pipeline link is here. You need ICD-10, the pipeline link is over there. And you see how to use them. So it's a nice starting point. Let's end today's session. And if you have any questions, please send an email to training@johnsonhopelabs.com. And you will receive all the recordings at the end of day 2. So tomorrow, let's say last session. So thank you and see you tomorrow.